Now I want to start with the new topic, next chapter, that is the inverse trigonometric functions. In this chapter, we will study about the sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x and cosec inverse x. Till class 11th, we have heard about the sine, cosine, tan, cot, sec, cosec, about these functions we have heard. And in my previous chapter, I have told you that is what is a domain, what is a codomain and what is a range. To understand the concept, to grab the meaning of the inverse trigonometric functions, we must recapitulate, we must start something about the trigonometric functions. If I discuss with you about the trigonometric functions, that is the first one, sine x. If sine x or sine theta is trigonometric function, then you know its principal domain. The domain of this function is any real number, but its principal domain is minus pi by 2 to pi by 2. Because maximum and minimum values comes in this interval and its range of the sine function is from minus 1 to 1. In place of sine x, if we talk about sine inverse x, if function is sine inverse x, in this situation, the domain of this will be minus 1 to 1 and the range will be from minus pi by 2 to pi by 2. So, what conclusion you can draw? We can see that in the sin x direct function, the domain was minus pi by 2 to pi by 2, or principal domain was minus pi by 2 to pi by 2, and the range was minus 1 to 1. But when we are discussing about the inverse of the same function, sin inverse x, we are finding the domain of previous become range of this and range of that one become the domain of this. So, as in case of sin x, similarly in case of cos x. In case of cos x, principal domain is 0 to pi and range is from minus 1 to 1. But for the cos inverse x, we say that its domain, it is the principal domain, this is the range. This range become domain. The domain of cos inverse x is from minus 1 to 1 and the range is from 0 to pi. Similarly, if we go about the tan x, you know the domain of the tan x is every real number other than odd multiples of pi by 2 and about the domain. But if we talk about the real domain, or you can say the principal domain of the tan x is open intervals minus pi by 2 to pi by 2 and range is any real number. So, in case of tan inverse x, its domain become range, that is any real number, and this principal domain become the range, that become minus pi by 2 to pi by 2. So, what you are noticing here, that in case of the inverse trigonometric functions, the domain become range and range become domain of the ordinary function as here explained you. So, in order to understand what are the inverse trigonometric function, it is very much necessary to know about the principal domain and the range of the original functions. Now, principal domain and range of cot, sec and cosec inverse functions. To understand it, we know that cot x, the principal domain of cot x is 0 to pi excluding 0 and pi, and range is any real number. So if we talk about cot inverse x, the range of cot will become domain for the cot inverse x and the domain become the range. So for cot inverse x, domain is any real number and range is 0 to pi. Now for sec x, we know that its principal domain is from 0 to pi, leaving the central value pi by 2, and range is r minus minus 1 to 1 excluding. So sec inverse will be r minus minus 1 to 1 will be its domain inverse of sec, and its range will be what was the domain of the sec, 0 to pi minus pi by 2. Now cosec x, if we talk about, for cosec x, the principal domain is minus 90 to plus 90 excluding 0, and range is every real number open intervals from minus 1 to 1, and cosec inverse x is r minus, because inverse is, so its range become domain and domain become the range. So ultimately we must be aware about the domain and range of the normal trigonometric ratios to understand, to calculate, to strike, to solve the problems based on the inverse trigonometric function. So only and only the mandatory part to understand the chapter is that what are the principal domain and range of normal trigonometric ratios, and what are the inverse functions domain and the ranges.